Alright, since we're already in here, I'm just going to show you guys some of the other stuff I found today. I had one of these when I was a kid. Probably 86, 87, somewhere in there. And it's a transistor tester. Hopefully it's not completely tacoed out inside. We're going to open it up real quick. Yeah, this one's different than the one I had. The one I had took a 9-volt battery. You know, I'm wondering how come all these battery companies make batteries that fail. And they have been for years and years. This is a really old Energizer. There might even be a date on here. It's made in the USA, so you know it's old. But this is what they used to look like. It says something on the bottom of it. It almost looks like it says Japan. Let me turn the flash off and see if we can see it. Can't read it, but anyway. Guarantee, we will repair or replace at our option any device damaged by our battery if sent with batteries to Union Carbide Corp. Box 606, Cleveland, Ohio. Guarantee void if either user or device recharges battery. Anyway, it's not too bad in there. Looks pretty good. So this is a transistor tester, and I had bought one when I was a kid, but I'm pretty sure mine had a 9-volt battery. I'm actually really glad this one doesn't. So, I'm gonna guess this is probably a newer one. And based on the number on here, I think maybe it might be a 1994. Especially because it's made in Korea. And I seem to remember mine was a little bit different. Power types. Okay, anyway. The output, I think, can go to a meter. I think. But I remember mine very well. So, and then we have a send cord. We're going to need to open this too. Who knows what's going to be wrong in here. Oh, jeez. This is even older. These kind of batteries very rarely ever went bad, which is kind of crazy. But they're carbon. All right, so on this one you have to loosen these. Okay, you won't get them out otherwise. Look at these. I remember these when I was a kid. There's just a general purpose battery, Union Carbide, ever ready, with the 9 lives. I'm totally gonna save these because you know why? They're not gonna go bad. They're not gonna leak. They never leaked back then. I wish I had a date on them. Size C, Union Carbide, general purpose. Look at that. Freaking cool. And we used to have these, we'd put them in our flashlights. They didn't last very long either. They're fairly kind of a light battery. I used to pull them apart, and the center post is made out of carbon. I used to take everything apart when I was a kid, man. I was constantly taking stuff apart. I'll probably clean this up and save this one too, just because it's kind of reminds me of when I was a kid. Both of these do. So this one here, what I'm going to do is I'm going to 3D print a C to AA adapter. I don't like dealing with C batteries. I might even just go get a 3-volt adapter and modify the send core, because I don't need a portable tester. I don't. So that would be Probably the best thing to do with this is not make it portable, just make it fixed. Now, this is not too terrible much going on here. They're using the transistor as an amplifier to get a signal to the meter, which makes sense. But and we could even build one of these if we really wanted to. But it's pretty neat. Very minimal amount of parts. Let's see, what do we have? We have a bias set, which is kind of cool. And this will teach you an awful lot about how transistors and stuff work too. But so the Sencor and Radio Shack, let's see, it'd be pretty much similar, although this has a transformer in it, so maybe it works differently. I can see the transformer. You need a couple of capacitors and a switch, and then this is basically bias current control. So you turn the bias current control until the light comes on, and that kind of gives you an idea of what it's doing, whereas this one will read on the meter, sort of. So now we have these really cool little things that test any device, but they break pretty easily. If you've ever seen any of those, I'll have to put a screen up with one of the modern ones. But anyway, these are cool. So let's go take a look at what you can get for testing transistors nowadays. All right, so here are some transistor testers. It looks like Finercy, or whatever you want to call them, come out with some new ones based off of the other kind. This will test pretty much everything. It identifies it and knows what it is. I know these are based off the other ones, but they're 29 bucks. They're pretty cheap. This one here, I don't know who in the hell would buy this thing. I do know some CB radio dudes that use these, but then again, that ain't saying a whole lot either. Just because you see somebody using one of these doesn't mean they're any good. And then we have these kind here, which are going to be based off of these kind, which are based off of these kind. And so you can buy one of these for 17 bucks with or without this little case thing, or you can buy one like that. They're all pretty much about the same, and if you're not careful with them, you'll break them. Oh yes, let's buy this one for $209. I'm sure it works a lot better. Here's a Finercy 79. Here is a combination pocket oscilloscope 3-in-1 DDS signal generator and transistor checker for $49. I mean, like, dude, that's pretty awesome. Here is a $15 one. Here's an $18 one, $20, $17, $79, $28. You get the idea. But and then I don't know what this one looks pretty cool too. But I had some of these early ones that look like exactly like this one with the orange board, and it worked great for a while until it quit working. And I don't know what happened, but it quit working eventually. Now, at the time that I bought them, they were $12. It was like, what? You can buy this thing for $12? Crazy. So, there's some really interesting stuff, though. Look at this one. It's got these crazy blue connectors on it. So, if you really want to be adventurous, boy, you can do some painful soldering and build your own. No thanks. So, I'm trying to think if I have a breadboard and a transistor laying around. I can put a battery in this thing and we can see if it works. All right, so I found some batteries. I'm just going to put these ones, I think, in here. They're lithium batteries. I don't know what to do with all the rest of my batteries. Yeah. I was dropping transistors. I get a couple of these RCAs. I don't know what they are. I assume something very similar to I gotta undo this. Something very similar to a pass transistor on something like an Astron 35. I have a bunch of them though. He made these screws really long. Okay. So these lithium batteries are less likely to leak. I don't know what I did with the little ribbon that went in there. Okay. So one thing that's interesting about this one is it won't tell you if it's NPN or PNP. You won't know. And you kind of have to figure it out. If we want to, we can take our meter here and put it in diode mode. And so we could kind of get an idea what's going on with this. Let's see here. We'll try. Get nothing that way. We get nothing that way. .7 volts this way, and then the other way shouldn't be anything, right? Oh, 0.64. Let's see. Because the transistor is essentially 2 diodes. But I don't know if this thing's any good. So let's get this off of here. I also have a regular transistor here too, but I don't know the pin out of it. And that's another thing that's really good to know, is the pin out ahead of time. So ECB, all right, well, let's just try. Okay. We get the base of it as the collector. I don't know if it is. I find it hard to believe. So this says conducting at 50. I guess 50 milliamps. So you turn it until it, oh, my hand's blocking it. Until it lights up. Okay, we'll turn it off. And if we put it on PNP, we should get nothing. Now, we don't know if we have these correct. What's the chances of me just putting this on here correctly? So we got the emitter and the base right here, and then the big part is the collector. I don't know if that would be true. Why don't we try switching the collector with like one of these other ones and make the base the base. I would think this should be the base, but I'm not sure that's how they do it. Okay. So we turn it all the way, we get nothing, lights up. Go to PNP, we get nothing. So basically, you got like 9 combinations, I guess, that you can try. And then you would like keep switching stuff around. So I'm just gonna try a few combinations just to make sure that it doesn't light up the other way. Okay. So it doesn't light up. And so basically we think that the collector is the base material here on this. I think that's usually how it is with these power types. And then the base and the emitter would be on one of these. So Okay. Okay, so we know it's not that. So we have the base and the emitter backwards. So there's the base, and there's the emitter. Come on. And it lights up. Okay, so we should be able to test the rest of these the same way. Okay. Let's try. So this one is a 2N6282 made in Mexico Motorola. 6282. 6282. I think this one might be different. A 2N3055. Also another thing here, we dropped this one, but they can be one side closer or the other. You see how they're closer? It kind of gives you an indication of orientation on these. So we'll start with the collector again, which I think should always probably be this material. And then we'll try the emitter up here and the base right here. Now, I have no idea if this is an NPN or a PNP. Okay, I'm going to say it's probably the same as the other one. All right. Maybe it's a PNP. Maybe it's completely different. All right. Maybe it's not even good. That's the other thing too. Okay, so we start with the collector here, the emitter, and the base. We get okay. We get nothing. Let's switch these around. This one might not be any good. All right. Okay, what else can we do? We can try that. This can take forever, dude. That one did not work, so I think it's probably bad. But we'll have to look up the pinout on it some other time. This is a A733. It's pretty common. Should be emitter, base, collector, usually. You see how that says emitter, base, collector on the other thing. Okay. All right, let's see. We could be probably the other way around. Come on, man. Okay. Then we go collector, base, emitter. We don't know if this one could be bad too. Any of these things that have been floating around in my box could be bad. Nope, that one's good. So this one has 35. I don't know what that means. The base current is at 35. This knob's also not correct. So right there should be 0. And let's see. Where's the marker? There it is. Okay, let's make sure. I'm going to put this thing at 0. Come on, man. Let's see. And then it goes to minimum. Minimum base current is 100. 0 to 100. I don't know what that would mean. Okay. Let's test this thing. Okay. Red is collector. Black is... This thing might be touching, so this might actually not be good. Interesting. Okay. Emitter. Okay, so the middle is the emitter. And the outside one's the base. Let's see. We try and get this thing in the other part. So we basically put it like this. Clock it around. Come on, dude. Come on. Wait a minute. Emitter. We need emitter. There we go. See? Put our transistor in there. Now, some of the Harbor Freight meters have an indicator for this, but this was back in the day when that wasn't as common, and you needed one of these. So this is pretty cool. So anyway, guys, that's it for me on that. We're dragging out the video, but we see the thing works just like it did back when I was a kid.